Hi everyone. Today I'm going to talk about Bernoulli process practice number 2. In this problem, we have a computer system that carries out tasks submitted by 2 users. In this problem, time is divided into slots. At any slot, the probability that the system is idle is equal to 1/6, and the probability that the system is busy is equal to 5/6. During any busy slots, the probability that the task is submitted by user 1 is equal to 2/5, and the probability that the task is submitted by user 2 is equal to 3/5. We assume events related to different slots are all independent. The answers to the questions in this problem can be found by considering suitable Bernoulli processes. Depending on the specific question, a different Bernoulli process may be suitable. For example, for some of the cases, we associate trials with slots, and in some of the other cases, we associate trials with busy slots. For part A of the problem, we have to find the probability that a user 1 task is executed for the first time during the 4th slot. Because events from different slots are all independent, tasks from user 1 form a Bernoulli process. The parameter of this process represents the probability that a task is from user 1 during each slot. That is, the parameter P1 is equal to the probability that a task is from user 1 during each slot. And this is equal to the probability that a system is busy during each slot multiplied by the probability that the task is from user 1 given that the system is busy. And this is equal to 5/6 times 2/5, which gives us 1/3. And then using the formulas for Bernoulli process, we can calculate the desired probability, which is the probability that the first user 1 task occurs in slot 4. And this is equal to 1 minus P1 to the power of 3 times P1, which is equal to 2/3 to the power of 3 times 1/3. For part B of the problem, we're considering the first 12 slots. We were given that among the first 10 slots, exactly 5 of them were idle. And we need to find the probability that the 6th idle slot is slot 12, given that 5 out of the first 10 slots were idle. Because events that happen during different slots are all independent, this probability is equivalent to the probability that slot 11 is busy and slot 12 is idle. And this is equal to the probability that slot 11 is busy multiplied by the probability that slot 12 is idle. Because events happen during different slots are independent. And this is equal to PB times PI, which is equal to 5/6 times 1/6, which gives us 5/36. For part C of the problem, we have to find the expected value of the number of slots until the 5th task from user 1. Let us define K as the random variable representing the number of slots until the 5th task from user 1. Recall from part A of the problem that tasks from user 1 form a Bernoulli process with parameter P1, where P1 represents the probability that a task is from user 1 during each slot. Therefore, k is a Pascal random variable whose distribution looks like the following. Probability of k equal to t is equal to t minus 1 choose 5 minus 1 times p1 to the power of 5 times 1 minus p1 to the power of t minus 5 for all t equal to 5, 6, 7, and on. And for all t less than 5, the probabilities are all equal to 0. Therefore, using the formula for the expected value of a Pascal random variable, we can calculate the expected value for k, which is expected value of k is equal to 5 over p1, which is equal to 5 over 1/3, which is equal to 15. Therefore, the expected value for the number of slots until the fifth task from user 1 is equal to 15. In part D of the problem, we have to calculate the expected value of the number of busy slots until the fifth task from user 1. In this part of the problem, we're considering a different Bernoulli process with only the busy slots, which means we take out the busy slots from the original process and form this new process with only the busy slots. The parameter for this new Bernoulli process is simply P1 given B, which represents the probability that a task is from user 1 for busy slots. Then, similar as part C, we now define a new random variable n, which represents the number of busy slots until the fifth task from user 1. So here, n is a Pascal random variable with order 5 and parameter p1 given b. Therefore, the expected value of n is equal to 5 over p1 given b, which is equal to 5 over 2 over 5, which is equal to 25 over 2. In part E of the problem, we're interested in a random variable that represents the number of tasks from user 2 until the time of the fifth task from user 1. What this means is that out of all the busy slots until the fifth task from user 1, t of them were from user 2 and 5 of them were from user 1. As defined in part D, that n represents the number of busy slots until the fifth task from user 1, we have n equal to t plus 5. That is, out of all the busy slots until the fifth task from user 1, t of them were from user 2 and 5 of them were from user 1. And therefore, we have t equal to n minus 5. From part D, we know that the random variable n is a Pascal random variable with order 5 and parameter p1 given b, which is equal to 2 over 5. Therefore, we can derive the distribution for t from the distribution for n. So we know that the distribution for the Pascal random variable n is equal to t minus 1 choose 5 minus 1 times 2 over 5 to the power of 5 times 1 minus 2 over 5 to the power of t minus 5 for all t equal to 5, 6, 7, and on. And for all t less than 5, the probability of n are all equal to 0. Therefore, the probability of t is simply equal to the probability of n at t plus 5, which is equal to t plus 4 choose 5 minus 1 times 2 over 5 to the power of 5 times 1 minus 2 over 5 to the power of t for all t equal to 0, 1, 2, and on. And for all t less than 0, we have probability of t equal to 0. Similarly, we can find the expected value of t from the expected value of n, which is expected value of t is equal to the expected value of n minus 5, which is equal to 5 over 2 over 5 minus 5. And this comes from the expected value of a Pascal random variable. And this gives us 7.5. And similarly, the variance of t is equal to the variance of the Pascal random variable n, which is equal to 5 times 1 minus 2 over 5 over 2 over 5 to the power of 2. And this concludes our today's practice on Bernoulli process.